Okay, hi, my name is Eris, and I'm going to, before getting into the lab, talk a little bit about the pre-lab stuff. Okay, so the purpose of this lab is to understand and determine the freezing point and the melting point of a pure solvent, and also whenever it's in a mixture. It's also making sure we know how to calculate this freezing point depression and experimental molecular weight. So some properties and safety, because we need to be safe here. We're really working with 3 different compounds. So we have water, of course, which has a molecular weight of 18.015 g/mol. It has a boiling point of 100 degrees Celsius and a density of 1 g/ml. While paradichlorobenzene, that's a long word, is 147 g/mol, has a melting point of 53 degrees Celsius, which will be helpful later whenever we get started into the lab, and has a boiling point of 174 degrees Celsius with a density of 1.458 g/mol. And then finally our naphthalene, we have the molecular weight, which is 136.22 g/mol, and its melting point is 82 degrees Celsius, and that's really all that we have about it. But also going into some of their properties, water, we know it's colorless, odorless, and it's a clear liquid that is pretty stable, so there's not different safety precautions that we need to take for it. Then paradichlorobenzene, it is white with a penetrating odor, and it is solid. It looks very crystal-like, if that would make sense. And all that you got to do is have it undergo normal storage methods, and that's really all, is to store it after you use it. Don't drain it down the sink, things like that. And then we have our naphthalene, which is odorless, and it's a white solid, a lot like paradichlorobenzene, and it undergoes and is stable under dry and cold climate conditions, so storing them the same way is completely plausible in being able to do that. So going into our pre-lab questions, the first question is, what is the formula and molar mass of the solvent used, and to draw the structure? Now, earlier in pictures you'll see the structure, but when explaining it, paradichlorobenzene is our solvent, so it's C6H4Cl2, and it has a molar mass of, like I said earlier, 147 g/mol. Our second question is the same type of one, but for our solute, which is our naphthalene, which is C10H8 and has a molar mass of 136.23 g/mol. Now, our third question is, what is the normal melting/freezing point for the solvent used in Celsius? So the normal melting and freezing point of our solvent, which is what I stated just a little bit ago in our properties and safety, is 53 degrees Celsius. Now, going on to question 4, suppose the acid starts to freeze before you begin collecting your data. Explain what you should do with the problem. So if an acid begins to freeze before you're able to collect anything about it, if the acid freezes before you collect data, then you should bring the acid back to a liquid state and try again. And that's it. So then for question 5, what is Kf, the freezing point depression constant for the solvent being used with the correct units? Okay. So the Kf for the solvent being used is 7.10 degrees Celsius times kilograms all over your moles. And then we have question 6, which is, what should happen to the temperature of a substance while the substance is melting, and why? So what happens to your temperature of a substance? It will remain constant because the heat being applied to the substance is being used to change its state. So if it's going from a solid to a liquid, it's really going to remain consistent with its temperature compared to it, because it's using that energy and heat that's giving it to in order to change it to a liquid state. So it's going to stay pretty similar. Then we have 7, which is if 10 grams of ethanol is dissolved in 100 grams of pure water, what would the boiling point and freezing point of the for the solution? And first you have to determine the molarity. So in the pictures, you will see the process that I take in order to do this, but to make this short and sweet, your TB, which would be, I believe, for your boiling point, is 100.0111 degrees Celsius, but while your temperature for freezing point is going to be negative 0.04 degrees Celsius. And that is all that it is for pre-lab, so let's get into the experiment. Okay, so we've already measured out our paradichlorobenzene, and mine's at 6.55 grams. And the hot bath is already at its appropriate temperature, which is at 54 degrees Celsius. So now it's time to put it in, and I gotta make sure that I start the clock. So I'm gonna set this in here, make sure it goes all the way in, and tighten it. Okay, so tighten. Okay. And okay, as you can see, the paradichlorobenzene is all the way in, and I'm starting the timer. Okay. And let me then also suspend my thermometer into here as well, and make sure that I'm not touching the edges as much as possible. We can see, so roughly right now, as we start this off, it's at, let me make sure that I can see it, it's at around like 28 degrees Celsius. And let me check my hot bath. Let me recheck the hot bath, and that's still at 54 degrees Celsius as well. Okay, suspending it in there. It's actually not getting up to 30, so that's pretty good as well. So what's happening here is that we are trying to melt this paradichlorobenzene into a liquidated form. And right now, it doesn't seem like I see any real difference. Of course, it goes along with time, but we have just started. So let's see. Okay. So now that we're up to the first minute, it has raised the temperature already in paradichlorobenzene to actually now 35 degrees Celsius, and I can see that it is starting to melt. So this is working. So let me take this. Let me stay here. Let me just keep looking at it, make sure that it's still working and all that's underneath, and it seems so. And I do not know what else to say during this. But what is happening right now is that we are just waiting for this, the solvent, to melt. And we are at the 2-minute mark, and it has already risen to 40 degrees Celsius in the solvent. And rechecking the temperature, it is still at 54 degrees Celsius. And so we just continue. It seems like I am seeing that there is a lot more of melting happening right now. It is looking more like a slushy-ish type mixture. There's still a lot of crystallized solid, but it is melting and making it look more slushy-like than it did whenever we first put it in. So now we are at close to the 3-minute mark, and it is around 44 degrees Celsius. And the hot bath is at now around 53 degrees Celsius, which is still in our range of its melting point, so we are still good there. It's okay. And make it just a little bit more hotter. Okay, so it is around at 45 degrees Celsius right now, and the time is 4 minutes. And our hot bath is still at between the 54 and 50 degrees and 53 degrees Celsius. Okay. So let's see what happens in a matter of another minute. Okay. So it seems like our solvent, as it is turning to a liquid, it still has the same coloration, of course. It's still this white, almost clearish, it's hard to explain, but it's more like a cloudy white than it is a solid white for its liquid. So it's kind of in between that clear and that solid. But right now we are at the 5-minute mark, and our solvent's temperature is at around 47 degrees Celsius, and it is at 54 degrees Celsius in our hot bath right now. So we still got a little bit more. It seems like a lot of it at this point has melted, but we're waiting for it to melt completely. And so as we continue to go on, you can see a lot of it has melted. And we're still at a good Celsius, 54 degrees Celsius for our hot bath. Okay. So we are now at the 6-minute mark, and our solvent is at 49 degrees Celsius. So it's getting a lot closer to this solvent's melting point, but it is getting close to our solvent's melting point that it, whenever it's said to completely melt by, but our hot bath is at 54 degrees Celsius. So as we can see, the temperature of our solvent is getting a lot closer to this like melting point, which in doing research for this lab and for our chemicals is said to be the range roughly of its melting / freezing point. Okay, we are getting close to our 7-minute mark here. And it seems like, it looks like that our hot bath is at 54 degrees Celsius, and our solvent is at 50 degrees Celsius, and a lot of it has melted. It's still not complete. There's still a good amount of solid left in there, but it has melted pretty much a lot more than it did at the beginning of this. So yeah, right now its texture is looking a lot more slushy like than it did before. At the first part of it, it still looked like there was solid mixed with a little bit of liquid, almost like if you leave like crushed ice out for just like a few minutes, how that would look. But now it looks very much exactly like you would get for like a slushie at like a movie theater. And it's, in observation wise, it is a cloudy white. And earlier, as I was, putting this together, the odor was very penetrative, as stated from doing research on what it should be, but also getting that whiff just from opening the bottle was pretty much evidence to me stating that it is very penetrative. Okay, so we're at the 8-minute mark, and our solvent is at 52 degrees Celsius, and our hot bath is at around 55 degrees Celsius. So I'm going to bring it down just a little bit, bring it more to a simmer on this hot bath. Okay. So it is very much, a lot more of it is liquidated than it was just previously, than I was explaining. Has melted down pretty much, I would say maybe around 80% melted at this point. And now we are at the 9-minute mark, and our temperature for our solvent is 53 degrees Celsius, and our hot bath is still at around 55. It'll take a little bit of time for it to kind of simmer down just a little bit. It's still within range, but we want to get that down to as close that we can. Okay, so we are now reaching 10 minutes, and the temperature of our solvent is at 54 degrees Celsius, and our hot bath is at 55 degrees Celsius. And there is still, if I can look a bit closer, there's still a good amount of it at the very bottom that is still not melted, so we gotta continue. But the majority of it has completely melted by this point. Okay. Let me just keep getting a closer look. Actually, as getting a closer look to the side, looking at it as it is liquidated, it actually isn't that cloudy white that I thought it was previously, because that looks to be more of what the solid is showing me than what the liquid is. From what I can tell, the liquid is completely clear. Now we're at the 11-minute mark, and our solvent is at 54 degrees Celsius, and our hot bath is at 55. So we still got some time before this is completely melted. So I don't really see anything different now than what I've just stated for observations during this time. But I will say that this process has gone a lot faster than I would have anticipated it to be for this mixture. So now we are at minute 12, and our solvent is at 54 degrees Celsius, and our hot bath is gone down to 54 as well. So they are relatively close, and especially in their degree to what it's needing. See, so for the hot bath, it's relatively at a 54.5, but our solvent looks to be at more of a 54, like 0.2, where it's a lot closer to the 54 than the 55 compared to my hot bath. So that's why I'm making a clear distinction that our hot bath is closer to 55 than it would be to 54. And our solvent is close to our 54. So now we're at the 13-minute mark, and it is at, actually has gone down to 53. Now it's a lot closer to 53, and our hot bath is at 54, and it's gone down as well to be closer to 54 than 55. And looking at it, it is almost completely melted. We still got some time because it has to completely melt through, but I'm trying to make sure to keep the thermometer away from the edges because that can, and of course due to human error and things that I'll talk about later, it will basically be a sign of human error as talking about its temperature of the solvent during this entire process. So I need to switch gears and turn back on my phone because it. Okay, so we're at 14 minutes, and our solvent is at 54 degrees Celsius, right on the dot, at least what it looks like, and our hot bath is at, I would say a 54.5, is getting pretty close to getting to 55 degrees Celsius. So, but it still hasn't completely melted through, so we got to keep continuing until this is completely melted. Let's see. We are getting close to the 15-minute mark, but based on observations that I stated earlier, I would like to restate that earlier I was wrong with what it looks like as a liquid. The liquid is clear while the solid has that cloudy white crystallized shape. So we're at the 15-minute mark, and looking back at it, our solvent is at 54 degrees Celsius, and our hot bath is at 55 exactly. Okay, there's still just a little bit left, so you gotta keep going. As you can tell, it's all just sitting at the bottom while the liquid, of course, is above it. But we're getting pretty close to our 16-minute mark. I'm gonna just agitate it just a little bit to see. Yeah. We still got just a little layer of solid solvent left. Okay, so we're at the 16-minute mark of this, and our Celsius degrees for this, our solvent is at 54, and it's getting close to 55 actually, and our hot bath is at 55 still on the dot. Okay. And now there's just a little bit of it left in there. So yeah. We are getting pretty close. It's at 16 minutes and 45 seconds right now. So we're getting pretty close to that 17-minute mark. And so looking back at our solvent temperature, it is at 54, pretty close to 55. And our hot bath is at 55 degrees Celsius. Okay. So yeah. There's still just a little bit left in there. just a tiny little layer at the bottom that shows how much is left. And agitating it just a little bit to make sure that that is not just like bubbles or anything. And it is still some of the solid para-dichlorobenzene. So we gotta just wait just a little bit more. Now I've gotta turn back on my phone because it decided to turn off on me. But we are at minute 18 and our solvent is at 54 degrees Celsius and our hot bath is at 55. So it's been roughly around that this entire time, which is good because it is close, very close and within range of the melting point that we've looked up for para-dichlorobenzene, which is at around 53, 54 degrees Celsius. So that's really good. And of course, human error is there, so that's why it's not exactly at 54, but it is as close as we can really get it at this point. So we are at the 19-minute mark, and our para-dichlorobenzene is at 55 degrees Celsius, while our hot bath is at 55 as well. So they're both on the dot, so they are either super close to each other's, whether it's hundredths or even thousandths, or they're at the exact same temperature at this point. And it seems like there's barely anything left. There's still a little bit because I can still see it if I agitate just a little bit, move around. So we got to keep continuing just a little bit to wait until it's completely melted. But roughly around this 19-minute and 36 second, it is almost completely melted. I'm going to give it just a little bit more time to make sure, but it's basically almost all melted at this point. There's still a few crystallized flakes in there, but we've got to wait until it's completely melted. And turn back on my phone. Okay, it won't turn back on. Okay, so turn back on my stopwatch. This is close to the 20-minute mark, and it is. And I'm going to stop the time there because it is completely melted through, and the ending time is 20 minutes and 19 seconds. And at this time, the solvent is at 55 degrees Celsius, while our hot bath is at 55 degrees Celsius. And so we've completely melted that down, so we're done with part A. You can stop now. There you go. Okay, so now I am putting our solvent into the ice bath and tightening the clamp to make sure that it stays in its place, and beginning our timer. So at the very beginning of this, looking at it, has gone down quite a bit. It is at 45 degrees Celsius right now. Okay, and looking at it and looking at my thermometer, I can tell that it has gotten pretty solid. Not super, very quickly, it's kind of turned more into a gel than anything else, but this is at around 30 or so seconds. So, have another reading. Actually, I was completely wrong and I misread. It wasn't at 40, it's actually at 51 degrees Celsius. I am sorry. But so at the first minute mark, it is at 51 degrees Celsius. I just misread the beginning. Okay. And looking down it is actually pretty difficult to kind of tell what's really going on in here because of having to put it in this ice bath, because with the ice being a solid white and not clear, it's pretty difficult to kind of tell what's fully going on while I'm trying to pay attention. So that might mean I need to pull this up just a little bit, maybe to see where there is something around the back that I can tell. But yeah, it is looking very, starting to get more slushy at this point, and we have reached the 2nd minute, and it is still at 51 degrees Celsius. While we're doing that, its melting point is at around roughly like 53, 54 degrees Celsius, so it hasn't moved that much in the matter of 2 minutes. And looking at it, a good amount, especially around the sides, have kind of hardened at this point and have gone back to their white texture. Maybe even looking at it as close as I can, looks like it is crystallizing. So it's trying to get back to its original state before we even melted it, so looking more crystallized than anything. Okay, we are at the 3-minute mark, and it has gone down now to 49 degrees Celsius. And our ice is still looking good. I'm looking down at it, just making sure I can tell. It looks like I said earlier, around the sides have gotten pretty white and have become solid, but of course we're going to have to wait for the middle too. And it looks like, when looking at it roughly around the sides, it's more kind of freezing outward in, from what I see. And yeah, so we're getting pretty close to the 4-minute mark. We're at 3 minutes and 50 seconds right now, so in 10 seconds I will state its temperature, the solvent, but I can clearly tell that it is getting a lot harder. At the 4-minute mark, it is now at 43 degrees Celsius, and I can see a lot of it has hardened. You can just try to move a little bit of the ice a little bit so I can see better. Now, looking at it, it's still pretty hard to tell if it's completely solid, but it's pretty close. It's a lot faster than I thought it would be because of the melting point took around almost 21 minutes. I'm still trying to look down and see if I can really see anything, see if it's completely hardened or not, because honestly it's too difficult to tell. It looks like it is, and we're at the 5-minute mark, and it is at 31 degrees Celsius. Because of me looking at it, it looks like it's almost completely solid. So I'm going to pull it up just a little bit, just so I can make sure. But looking at it, it looks completely solid at the 5-minute mark. Let me take a check. It is at 5 minutes, and at 5 minutes and 30 seconds, it has completely became solid again. Yeah, it's completely solid. You can stop recording, sorry. Okay, so I just added 1.53 grams of naphthalene into the solvent, which was 6.55 grams of paradichlorobenzene. That was completely melted, so I'll be starting the timer now. And at the beginning of this, It is at 55 degrees Celsius for my hot bath, and I'll be checking and agitating just a little bit my naphthalene mixture with the solution of naphthalene with my paradichlorobenzene, and it is at 41 degrees Celsius at like the 0 minute mark, like just beginning. So from looking at it, the naphthalene is also a lot like your paradichlorobenzene, except for that is odorless. But of course, because we already have the paradichlorobenzene there, it kind of is harder to tell if it is or not, because just such the penetrating odor that paradichlorobenzene is. But continuing at the minute mark, the temperature in our solvent mixed with our solute is at 46 degrees Celsius, and our hot bath is at 55. So talking back with the observations, it is a lot like paradichlorobenzene in the way that it is crystallized, but it is also this like white, cloudy texture already. But we're pretty close. There is only 1.53 grams of it in there, so comparing it in terms of grams, it is a lot less than how much paradichlorobenzene that we had to put in there and melt. So I am hoping for it to have a faster process. So we're reaching the 2 minute mark, and it's already up to 50 degrees Celsius in our solution. And our hot bath is still at 55 degrees Celsius. So it does look like it's going a lot quicker than it did for the paradichlorobenzene, which is a surprise to me because of naphthalene's melting point is at 80 to 82 degrees Celsius. Most likely the reason why could possibly be because of the reaction maybe taking place when with the mixture of paradichlorobenzene. That's my hypothesis on this. So we are reaching the 3 minute mark in around 10 seconds, but a lot of it has already melted. There's just maybe a little layer left on the bottom. So now we're at the 3 minute mark, and our solution is at 53 degrees Celsius, and our hot bath is sitting at 55 still. It really hasn't changed barely at all. Our hot bath's temperature, it's basically been almost right at the dot the entire time. Yeah, it is almost all the way melted through in a matter of 3 minutes. There's still some left because I can see it based off of it being a more solid color compared to whenever naphthalene is melted into a clear liquid, just like paradichlorobenzene. We are at our 4 minute mark, and it looks like for 4 minutes our solution is at 55 degrees Celsius, and our hot bath is at 55 as well. So they are roughly at the same temperature right now. And let me just make sure. And this is where I stop at 4 minutes and 16 seconds. The naphthalene mixture with paradichlorobenzene has completely melted through. Okay, so I am now adding our mixture into the ice bath and tightening the clamp on it so it stays, and beginning our timer. So at the very beginning of this, just looking at it, our mixture with our naphthalene, with our paradichlorobenzene has a temperature of 47 degrees Celsius. So it's already, as it's been added to this mixture, has gone down a good bit. And trying to take a closer look at it, looks like there is like a little bit of what it seems to be condensation on some areas that are just air pockets because of the ice not fully going in. But we are getting close to our minute mark. And so once I get to there, I'm going to state the temperature. Okay. So we are at our minute mark, and the temperature for this solution is now to 39 degrees Celsius. And just looking at it, I can tell that some of it has already hardened at the bottom. And it seems like it is going to be a white solid again. And because of course from looking at it, it has formed some crystals. Yeah. Let's see. Let's see if there's any observations that I can make right now besides what I just stated. Nope. Okay, so we have reached the 2-minute mark, and our solution of methylene and paradichlorobenzene is at now 38 degrees Celsius. It seems roughly still the same as it was maybe 30 seconds ago. You can see that there's like just condensation, and off to the side of it there is a good bit of it that has already became frozen. Just looking at it, being able to have like a view of it. Let's see. So about 10 more seconds. Okay, so we're at the 3-minute mark, and our solution has gone down to 35 degrees Celsius. But yeah, I can see around the edges that it is forming a solid, which is good because we're freezing it. Wonder, because of how fast the mixture between naphthalene and paradichlorobenzene melted, if it will freeze faster as well, but it almost seems like it's not the case because it's getting pretty close to that time. So we have reached the 4-minute mark, and the temperature is at 32 to 33, so maybe like 32.5 degrees Celsius. And looking at it, it seems like there's still liquid in there. You can clearly tell, but around the edges has fully frozen over. So now we're just waiting for the middle to freeze. So okay, so we're getting close to 5 minutes. Let's see, 10 more seconds. Okay, so we're at the 5-minute mark, and our temperature is at 30 degrees Celsius. And trying to take a look at it, there's still liquid left in the middle for it to freeze, so we've got to go just a little bit longer. I believe, just trying to remember, back is actually taking a longer time than it took for the paradichlorobenzene by itself to just freeze over. So, let's see. Take a closer look at this, make sure. Okay, so we're reaching the 6-minute mark, and our solution is at 28 degrees Celsius. And I'm getting a little suspicion that it looks to be almost completely frozen. It's kind of hard to tell now at this point, so I'm going to need to pull up just a little bit to kind of check. Seems like there's still just a little bit left. So let me fasten this back in. Okay. We just have a little bit of a liquid left. Freeze over. So we're getting close to the 7-minute mark, and it seems that, well, our temperature is at 26 degrees Celsius, and I really need to check it again to make sure. I'm going to have to take this out for a second and check, because I think it's completely frozen over. So let me check this. Yes, it has been completely frozen over. So at 7 minutes and 25 seconds is the time that it has completely frozen over.